Okay. So to start with, I think the session, like what exactly it is going to be. So that as the topic suggests, it's going to be on Web3. Like it's a new buzzword in the market right now. We used to talk about Web2 a lot. We used to kind of, you can say, deal with Web2 a lot in our day-to-day life. Like we didn't define it earlier, but when blockchain came into existence, then this new word came into also existence called Web3. So Web3, like kind of, you can say it's mostly a word where you can say you can talk about distribution, decentralization, where the control is with a person instead of a particular intermediary. So before I think I should start the video. Yeah. Okay, so we are going to cover these topics as you can see. We are going to talk about blockchain in basics. We are going to talk about Web3, like what are the benefits of Web3 over Web2, and how we are adopting blockchain actually, and what are the actual challenges we are facing when like onboarding new users on Web3, because we are quite reliant on Web2 right now, and it becomes sometimes difficult to kind of, you can say, explain that benefit of Web3 when there is a robust ecosystem of Web2 already exists. So we are going to talk about all those things. Then we're going to talk about some development needs which we use in our day-to-day development cycles. We are going to talk about some architectures. Maybe, we will talk about basic blockchain architectures. We will pick one, I think, one public blockchain and one private blockchain to explain what are the components inside which actually plays a role to make this system that huge, which the name suggests it is. So, and then we will cover some use cases like which you might work on in future, and you, if you want to kind of, you can say, have a future in blockchain or in Web3, then I will suggest some things like how you can start and how you can kind of, you can say, start with a particular point and reach at a particular destination. So we're going to talk about that, and then there will be a separate Q&A session there. Maybe you can clarify all the questions, and if we don't get enough time, then yeah, we will try to cover all those questions. I will try to share my profiles with you. I've already shared with analytics with the team, but I will also try to share it in the chat channel. I will try to give the communication medium where you can talk to me, and maybe I will try to answer all of your questions as well. So before starting anything, so let me just talk about myself a little bit. So my name is Mohit Vashistha, as it is visible on the screen. So I'm leading technical team, or you can say the blockchain team at OP Games Singapore, and I've been in blockchain and in Web3 space for last 4.5 years, more than 4.5 years now. And I've been working on a lot of stuff. So I've been working on multiple blockchains like Ethereum, as Akshay also mentioned about other blockchains like Polygon, BSC, Hyperledger Fabric, and a lot more. Web3 is a component. So Web3 is something we call the kind of, you can say, the whole ecosystem of Web3 when the system is decentralized or when the system is distributed. And sorry for that. Uh, yeah. Then I have also done some product design and development. I have architected a lot of blockchain solutions as well. And coming to hobbies, so I like to travel. I like to gardening sometimes, and I like to cook as well. So yeah, sometimes I do these things in my free time. So yeah, what exactly is blockchain? So as the name suggests, it's nothing but it's a chain of block. Now, what exactly is a block? So block is nothing. You can say it's a block of data. Now you can like, let's take a simple example. Let's say, for example, if you take a notebook or if you take a diary has a lot of pages, right? So or you can say, you can call it a ledger in that term. And let's say, for example, it is in a spiral shape. Spiral binding like has been done on this particular notebook or a particular diary. So just understand your page as a block. Now, what this page actually contains. For example, let's say, take a simple example. let's say I want to send any of you some money. So I will have a bank account and you will have a bank account, and I'll have to transfer some amount. So I will record some basic information about that transaction. So transaction is something where someone sends something to someone, right? So let's say, for example, I'm sending an amount, let's say, for example, 100 US dollar or 100 rupees to, let's say, for example, person A, and the amount is 100. So let's say I record this transaction on page line 1. And similarly, let's say, for example, you all do such transactions, and all those transactions get recorded on that page on paper, for example, right? So now coming on the digital media, like what exactly blockchain does. So this block actually kind of, you can say, accumulate all these transactions which we do on blockchain, and it kind of, you can say, combine all those transactions and create a unique identity out of it, simply. So it's like, you can say, that page has a lot of transactions, and those transactions kind of, you can say, link together and then make a single block. Now how these connected, how these blocks are connected on a diary or on a spiral notebook, right? They're connected with a particular, you can say, connection, right? So there is a connection for page for page 1 and page 2, right? Like after page 1, page 2 will come. Similarly, after block 1, the block 2 will come. After block 2, the block 3 will come. And similarly, we will keep recording the transactions. So similarly, one page is your kind of a block, and then you create an identity of that page. You can call it page 1. In blockchain, we call it block header, or you can say block identity, block hash, right? You can call it anything. So simply, like to summarize, so blockchain is simply an immutable time spent stamp series record of data that is distributed and managed by cluster of computers. So now let's break it down first. So the word immutable comes. So immutable comes from, you can say, you cannot kind of change the data on a blockchain. So it's simply, if you have put something on a paper, so you can it's like you have written something, now you can't change it, simply, right? If you have to make a transaction to redo that, to undo that transaction, you will have to make another transaction. For example, let's say I have transferred mistakenly to someone. So it's not a good example I'm giving, and it's not the purpose as well, but I'm just, for the purpose of explaining, I'm saying that, let's say, for example, if I want to redo something, let's say I have transferred to person A, so I have transferred 100 USD. Let's say it was a mistake, so I can ask the person A to transfer it back. So that's how, like, we will have to create two transactions. It's not like we can modify that data. It's not like we can revert that transaction. It doesn't happen in blockchain. It's an immutable piece of data. Once you have written something on blockchain, it's there. Like it will always be there. So now, what is timestamp? So timestamp means, like, the data, whenever you write it, it comes with a particular timestamp. Let's say, for example, if I write now, so that will also have a timestamp, and that timestamp will also be there with that transaction, right? So every transaction will be timestamp. Means at any time you do a transaction, it will have that time, like whenever you do transaction, and that is when we can call it like a timestamped data, right? Now series, like timestamp series, we can call it, because it's a number of records. Because in page, like, we will keep a number of records, like, let's say, for example, 20 transaction, 30 transaction. It depends on the size of the page, right? If it is small, it can be 10. If it is big, it depends on how, like, which type of notebook have you purchased, or you can say which type of blockchain you are using, right? Like, let's say, for example, Ethereum is a platform, right? It can define a block size of 2 MB. It can define a block size of, like, let's say, 2 KB. It can be anything, right? So it can be, it depends on what kind of blockchain you are using, the block size. So it's a like timestamp series record, right, of data. Now data is something which is, like, you can say, you can call it transactions, or you can, so even in our traditional databases, right, we call a particular database record as a transaction, right? So it's simply like that, a database record, or you can say a immutable record which we are adding on blockchain. And now, what is the word distributed means? So distributed means, for example, let's say we all are part of a particular blockchain. So the copy of this blockchain will be with everybody who are part of this ecosystem. Now comes the question that, okay, like, if it is with someone, like, where is my privacy, right? So Actually, it depends on what kind of blockchain you use. You are using public blockchain, or you are using private blockchain. So it depends on that. Now comes to, like, you can see the data. Yes, like for the transparency or for the trust, it was designed in that way. Like you can see the data on the public blockchain for every transaction, but you cannot actually dictate the identity of the user, because the identities are defined in terms of public keys and private keys. So whenever, let's say for example, I want to become a part of Ethereum blockchain, so I want let's say for example, my computer wants to become that part, right? So we are saying cluster of computers, right? So cluster of computer means combination of multiple computers are connecting in an ecosystem, right? So let's say for example, I am a new user of a Ethereum blockchain. I want to become part of that blockchain, right? So what will happen is the ecosystem will provide initially identity for me. So that identity is in terms of public key and private key. So now, let's say for example, as soon as I join the network, all the public keys, for example, let's say all of you are all 43 of you are participating, okay, and you are already part of the network, so you will also have a public key, right? So that public key, all of your public keys will be given to me, and my private key will be with me only, right? And my public key will be broadcasted to each of you, so that if any communication you want to make with me, so you can make with that identity. And that public key is in terms of hash, or you can say it can be a hash, or it can be a hexadecimal number. So it's as we use like sharp 256, that is very technical. I don't want to go deeper there right now, but it's like, you can say, you get an identity in terms of hexadecimal numbers. You might all understand hexadecimal. It starts with 0 and ends with F. So 0 to 9, and then A, B, C, D, E, F. So and it's a string of 256 bit length. So it's not like Mohit, or it's not like a person A, person B, or Akshay, or anything, right? It is something different. It is not like, you can say, recognizable. You cannot recognize everybody with their public key. You can call it an address also, and you can actually in public blockchains, address is actually derived from the public key. So the actual public key is not your address, but we call that because we derive it from there. But actually in Ethereum blockchain, it is of 160 bit. The address is of 160 bit, but your public key is actually 256 bit. So from your 256 bit, your address, like your identity, is defined, right? So every blockchain can have their set of rules. Okay, so now coming to the definition again. So let me just, okay, can we hide this here? Okay, so coming to the definition again, let me, okay. So now blockchain provides security. It is a single source of truth, and it is disintermediate. So I will explain all of these. It is transparent, and it provides trust. How it does that actually? So security, because let's say for example, if I want to do a transaction, okay, let's say for example, I got my identity in terms of a public key. So whenever, let's say for example, I want to send Akshay some amount, right? So I will use the public key of Akshay, okay, and now I will sign this transaction with my private key, and my private key is with me only, right? You can call it, you can say, a password I have, okay, and I will encrypt the data using my password. You can call it, I have a secret, and with that secret I can encrypt the data, and that data will only go to the receiver, because I have used the public key of the receiver. Okay, so there is a sender and there is a receiver. So we use the public key of the receiver and encrypt the data with the private key of the signer, and it becomes a digital signature actually. Okay, so it actually becomes you can say a signature, or you can say hash. So hash is something where you get a defined length of any input you give. So your transaction is your input, and you get output in terms of hash only. Okay, so you actually, so the conclusion is that you can't see the data in terms of plain text. It's not like Mohit is sending Akshay some amount. It's not like that. It's like a hash is there, sender hash is there, receiver hash is there, and amount is there, and that transaction makes a new hash out of it, because the all other information was an input, and then output hash is there. So it actually, the whole data transfer in terms of hash, and hash is actually one-way function, so you cannot go back from output to input actually. Okay, so you cannot even define the sender, receiver, and the amount from the output digital signature. So that is the property of the hash actually. I will explain cryptographic hash function in my slides later. So single source of truth, because everybody have that copy. Everybody is actually holding a kind of, you can say, a ledger. So as I explained in terms of diary, so every diary will have same records, but in terms of hashes only. It's not like in terms of plain text. So it's a single source of truth, means that diary will not change for anybody. It's not like if you are connected to a network, so the ledger will be different for me and for the other person. It will be not be like that. So it's a single source of truth, so anybody sees their data, it will always be the same. Okay, now there is no intermediary actually. So if, let's say for example, take an example of a banking transaction, right? Let's say for example, in India, if I want to send someone some Indian rupees, so simply my bank is my intermediary. Simply I am transferring the amount to the bank, and then bank is sending the amount to the other person to whom I am sending the amount, right? So the bank does the settlement. It means there is an intermediary, and there is always a cost comes with any intermediary you put in between. Okay, so like bank is actually charging for your debit card fees, your there are a lot of fees actually, like monthly, quarterly, or yearly. There is a charge for that, and some banks doesn't as well. So it depends actually what kind of bank you are using. I just want to explain, like, there is an intermediary, there is a third party in between who actually settles a transaction in Web2 space. So banking is an example of Web2 space. But let's say, for example, if you deal in Web3, the transaction is actually happening between two people only. There is no intermediary. Like if I'm sending to someone, it means we only, like, these are the only two people responsible for that particular transaction. Now comes to the transparency. Why transparency is there? Because in terms of public blockchain, the data is publicly visible. Like you can view the data, but it is in terms of hashes. You can verify like whether a particular transaction was happened or not, but you cannot actually kind of, you can say, deduce if you don't know some particular if you don't have particular private key to see that particular data. So if the transaction was done by me, so I can see the data, and I can decode that as well in terms of plain text also using smart contracts. But if somebody else wants to see the data, and if they don't have the permission, it means like they'll have to have a private key to see that data. If they have permission, if the data is public, they can simply see that. Okay, so now the trust comes with the consensus mechanism. Actually, consensus is nothing but an agreement. So for example, let's say whenever let's say whenever a particular transaction is played, let's say for example, I am doing a transaction to someone else. So it's simply, you can say, everybody can join the network in public ecosystem, in public blockchain ecosystem. So there is a consensus mechanism which is running algorithmically. So there are proof of work, there are proof of stake. So I will not explain them technically, but it is something, you can say it is a mathematical algorithm or mathematical formula, like which will actually dictate whether a particular transaction is actually kind of, you can say, valid or not. If it is valid, and if it is following all the criteria which a blockchain has defined while starting the blockchain, so then like you can say it will accept a transaction. So that trust comes in because like anybody can become a kind of, you can say validator, or you can say the miner. Anybody can become a validator. They can simply verify using that algorithm. So now this is the explanation of blockchain. So I will go a little bit deeper how it works. So for example, let's say I am requesting a transaction. Okay, so now this requested transaction will be a kind of, you can say, broadcasted to the network. Okay, so this network is nothing but a cluster of computer nodes. Okay, now it will go to each and every node. Okay, so now the validation process will run. Means the miners or the validators will check the validity, whether the format is correct, whether like it is where should this transaction be included, in which block it should be included, and what is the timestamp of this transaction. All those validation happens in between. Okay, now a verified transaction can simply kind of, you can say, if it is a cryptocurrency transaction, so actually transaction goes through smart contract, so that piece will come in later. So like it's a, you can say, code written for that. It's simply high level code has been written, and we kind of, you can say, send our data through that code to the blockchain. Okay, now then simply this is the, for example, new block, right, containing all the transactions, containing this transaction as well. Now this will be broadcasted here, and it will be, once it is, once the validation is correct, it will be added here. So so it can be a cryptocurrency as well. Okay, and cryptocurrency has many, there are many types of cryptocurrencies, so we'll not talk about cryptocurrencies a lot because this is a basic session. So you can call cryptocurrency as a use case of blockchain. So don't think that like I just want to break a myth with a single sentence. Cryptocurrency is actually not blockchain. Cryptocurrency is something, you can say, it's just a use case of blockchain. It's one example of how to use blockchain simply. If I call banking system, so banking system is simply a use case of Web2 applications simply. So similarly, cryptocurrency is a kind of, you can say, an example, or is a use case, or is an application medium through which we transfer value, right? So, and we create value in terms of digital, you can say, identity, or with digital identity, kind of, you can say, I hold some amount, and I hold some cryptocurrency, and it has some value. Value comes with trust. For example, if I believe in Bitcoin, it means it will gain the value. It means if I believe in something, it means I will purchase that, right? So it will simply kind of, you can say, I will give some value it, right? I will purchase it with some amount. Similarly, if all of you are interested, so it means you will pay the amount. So the value actually comes with trust. So if a particular community, let's say for example, let's call a country, right? Like let's say for example, USA. Like USA believes that USD has some value, right? So actually they have a trust on that particular, because it's a paper, right? It's nothing like you have printed something on a paper, but you believe that a particular note is of 2 USD worth or 1 USD worth, and that actually the trust is there, and that's why it has that value. Okay, so that is what actually the cryptocurrencies are. Now, coming to the differences, so there are two types of blockchain actually exists. So one is the public blockchain, where everything is visible to everybody. Again, like if you don't have the private key of others as well, you can see the data. But still, there are a lot of use cases in public domain as well. Let's say, for example, let's call the governance system, right? So let's say if I want to create a transparent system where nobody can say the EVM was hacked, right? So simply we can use blockchain in such cases, right? We saw an example recently by a UP police a member as well. So like they are actually recording all the complaints on blockchain, right? It means everybody can see all those complaints, and everybody can track there, right? And they're reliant, they're trustworthy because it is on blockchain, because it is an immutable data. Nobody can change their data, right? So once it is recorded, it will always be there, and everybody can see what exactly happened with a particular complaint, right? So we need public blockchains in such kind of infras, because we are kind of, you can say, we need some transparency in such kind of systems. But let's say, for example, if I'm a business owner, right? I don't want to share every detail out of my business, right? Because there are a lot of competitors. For example, let's take an example of e-commerce itself. Amazon is there, Flipkart is there, then there are a lot of small other players, right? Like Myntra and all others, right? So simply one competitor doesn't want to be kind of, you can say, lag behind from the other competitor. They want to be ahead, right? So they will not like share the sensitive data. But what exactly is the requirement of permission or private blockchain? The requirement is there. They want to make their data secure. Like it means they want to create a ecosystem or DB store where their data cannot be changed. Data cannot be modified, right? So that kind of system where you have some control, it means you have some access control by some, you can say, known players. So a public blockchain will be, you can say, the ecosystem will be created created between only the known members, but a public blockchain will be kind of, you can say, that ecosystem will be created to the unknown members. It means if anybody can join the network and run a full node and mine the transactions. So don't go technical, just understand, if you can, if everybody can join a particular blockchain network, it means it is a public a blockchain network. If there is a restriction in joining the network, in terms of roles or in terms of access control, like you can only do certain functionalities on a particular blockchain, it means it is a permission blockchain. It means someone or some group actually has that access or has that power, who controls the network. So on public blockchain, anybody can do a transaction, and on private as well, anybody can simply do a transaction. Okay, I think it's the same thing. I have, I think, pasted here. So, the private part is, I think, the same. So let me just explain you. So that was, I think, a mistake from my side. So on private side, anybody cannot actually join the network. So it's like it's permission environment. Like you need permission for that. And on public blockchain, anybody can do a transaction, but on private, only a certain number of people can do a transaction. And now coming to the audit. So let's say, for example, I gave an example of police complaints. So anybody can simply audit, like which police complaint was raised when, for the public records, right? So on public blockchain, anybody can simply audit, like whether particular data exists or not. And on private, only a certain, you can say, a number of members who are part of that blockchain, who have that access, can access that data. Okay. So now coming to let me just give you an example so you understand where I'm coming from. So these are the example of public blockchains. It means like anybody can go and join these networks. So simply Bitcoin is an existing network where you can go and join the network. Simply it goes with it goes with Ethereum, Algorand, Cardano. There are a lot of others like Polygon, like Binance Smart Chain. You can like there are a lot of blockchain which exists. So you can, if it is public, you can simply join it. So you can read about all of these platforms, and it's like Bitcoin uses proof of work. Ethereum used to use proof of work, but now they have shifted to Ethereum 2.0. So now they are using proof of stake, and Algorand is using pure proof of stake. So it's an consensus algorithm I'm talking about. So you can kind of, as I said, you can configure a particular blockchain. If you are creating a blockchain from start, like you can decide what kind of agreement algorithm you want to use. So there are hundreds of agreement algorithms which are existing. So you can use any of them. So similarly, Cardano, like it's a proof of stake chain, but designed as an alternative to proof of work network. So you can explore any one of these or all of these as per your interest. And then example of permission blockchains are Corda, Hyperledger. Hyperledger, the whole Hyperledger ecosystem is a permission environment, but mostly like which is used is Hyperledger Fabric. But there are a lot of other Hyperledger projects, like you can explore Iroha, and there are a lot of others, Indie and all that. So then Quorum is also one of the examples. So it's an Ethereum private chain. So this was an initiative which was started from the Ethereum community itself, when there was talk about some secretive data or some data like which cannot be made public. So for that purpose, the Quorum was introduced. Now, so this was all about Web3. So because of constraint of time, I will not take questions now, but you can collect all your questions now on blockchain, and then I'm moving to Web3. Then you can collect all those questions as well on Web3. So now what exactly is Web3, right? So this buzzword is going on. Our actual you can say title of this talk is Web3 itself, right? So Web3 is nothing but it's an environment where the control, or you can say the control is on the user side, not on the intermediary side or on the owner's side. So let's take an example of Facebook right now. So what Facebook actually does, right? And if Facebook is not charging anything from us, where exactly the revenue is coming from, right? So now let's first talk about how Facebook functions, right? What we do, we upload pictures, we give our personal details as well, and we do a lot of other things, like comment and share and a lot of other things, right, on Facebook, right? So what exactly Facebook does with their data is they actually store their data, and they use that data like to kind of, you can say, give recommendation of what we like. For example, let's say they are running ads, right? So let's say they are running an ad of a particular item. Let's say, for example, airports. They're running an ad of airports. If I like the airports, it means, right, like I have some interest in airports. So it means it will start giving recommendation that, okay, this particular person likes the airports. It means he might need it or she might need it, right? So they will start giving recommendation, right? So that particular, now who will pay Facebook? Apple will pay Facebook, because Facebook is actually helping Apple in marketing or in advertising, right? So they are making use of data. And who is making that money? Mark Zuckerberg, right? Mark Zuckerberg is making all of that money. And whose data, like who like the airports? I like the airports, right? Or for example, let's say any one of you like the airports, right? But if you liked it, why didn't you get the value out of it, right? Why Mark Zuckerberg got paid? Because he created the ecosystem. Yes, that's a valid point. But like at least I should get something right out of it. I should get at least some share out of it, because if I haven't created the ecosystem, but still I'm giving my data, right? So now here comes the user control. User doesn't have control actually on a centralized ecosystem, or you can say on a web2 ecosystem. The web2 ecosystem is something where the control is with some like defined parties like Facebook, Apple, and Google, and a lot of other companies which are existing and which are big right now, because they are big because of people, right? Because of people's data, because of people's money. If everybody is investing 1 cent and they have a user base of, let's for example, uh, uh, 5 billion, right? They can make a hell lot of money out of it, right? Simply. So it's like if a user gets something out of its data, and it means like they can get some value out of their data, right? So when we move the control from a particular defined party to the users, it means we make the applications user centric. Then we call the ecosystem Web3 actually. Now the one more statement comes for that is like who actually controls your data, right? Mark Zuckerberg controls your data. They can see, right? Like whatever they say that it is end-to-end encrypted and everything, but our data is flowing, right? Our data is flowing in many ways. They can decode it because they have written the encryption algorithm, and who knows whether it is symmetric or asymmetric. If it is symmetric, they can simply kind of go back and see our input as well. So it means your privacy is not there. Like you are not your data is not private. Simply, if you need privacy, you'll have to move to user centric applications, not the customer not the intermediary centric simply. So let me just define what web 1 was, and what when web 2 came, how it evolved, and then the web 3. So in web 1, simply it was nothing but like email kind of like simply user, you have user ID, you have a password, you can simply log in, right? Then came the like web 2 space, like where your control is with you can say some third party, and like Facebook, Twitter, GitHub. So this is actually web 2. Okay, so now we give control to someone to let's say for example hold our funds, we give control to bank. To hold our data, we give control to like personal data, Facebook and Twitter and GitHub like for our professional data, right? They hold their data, right? Let's for example, if I'm working for a company and if I have a public GitHub profile right now, we have an option of private and public features, like whether I want to make my repo public and or not. But still, like GitHub has that access, right? GitHub, if GitHub wants to use my idea or use my code base, they can simply do that, right? So and nobody is actually seeing that. There is no regulation on that as well, right? So now comes the web 3. So web 3 is something where you own your private key. Now your password used to be secured by Facebook, Twitter, or GitHub, right? So you see a lot of hacks where you see, okay, personal data of these many customers got leaked, right, with that company, with that company, from that company, right? So actually your personal data is gone, right? But in web3 your personal data is with you. It means like your password is stored on Facebook, it means it is stored on web2, but your password, or you can say your private key, is actually not stored on web3. So you can use some ecosystems where you can store it, but again it moves you towards web2. So actually so in these wallets, so these are actually wallets, Coinbase wallet, Wallet Connect, or MetaMask. What they do is they are a user interface which provides you your public key and private key. So they will say, okay, you will have to store your private key with you, and we are, if you lost it, then we are not responsible for the you can say, we cannot actually kind of, you can say, make it again, because it's a process which only happens once. Okay, so you cannot kind of define something again in terms of public and private key. Once it is gone simply. So now I will give just a sentence for the challenge. The challenge is we don't want to take the responsibility, simply because we are over reliant on such ecosystems. Let's say bank is taking care of my funds, why should I worry, right? But for example, let's say it's a small bank, right, for an example, right, and it goes bankrupt, and now what would happen with you, right? Your money is gone simply. So if your fund is in a non custodial environment, non custodial means and somebody is not taking custody of your funds simply. So I mean, like, you are the responsible one who is taking the custody of your funds. So simply you own your private key, you own your funds simply, and you can use them as the way you want simply. So this is the actual difference in web 1, web 2, and web 3. Now I will explain what exactly is web3. So web3 is simply it's a third generation internet where the devices are connected in a decentralized network rather than depending on server based databases. So server based databases means the server is simply owned by Facebook, Google, Microsoft, GitHub, Twitter, right? So it means that your data is with someone else. If the data is decentralized, it means the computation happens anywhere, right? We don't know the validators in public ecosystem, in public blockchain ecosystem, right? It is stored actually with everyone, but in an encrypted manner. Only the person who has encrypted that particular private key can see that data, right? So I mean, in public blockchain, you can see the data, but you cannot change the data, right? So it depends like what kind of infra you are using. So I might be confusing you guys like with saying you can see the data and you cannot see the data. So it depends like what kind of blockchain you are using. If it is permission, it might have some access control, but if it is public, everybody can see the data, right? Okay. Now so as I explained the difference, so web 1 is like basic HTML and emails and all that. So like the information centric, or you can say the interactive interface which we see today, where the passwords are stored or your data is stored in servers, that is actually web 2. And web 3 is something where you own, or like it is a private, secure, and decentralized environment which is user centric. Okay. So now the benefits are like a lot. So anti-monopoly, it means like one person will not get the benefit out of it. Like it is pro privacy, like it is like your data will be private and you will actually get the value of your data. Then the network is secure because of the cryptography involved. Actually asymmetric cryptography is involved in that. So like if you take the like most powerful supercomputer in the world, you cannot actually break SHA-2 because you need, if you try with brute force, so you need at least 2 to power 256 combination to run, because it's a 256-bit algorithm. You get a 256-bit hash. So if you will like you can say try to make combination, you will have to make these many number of combinations, right, for the brute force to hack a particular private key or something like that, right? So it's a secure network. The data ownership is yours, like it means user owns the data, not a particular third party intermediary. Then it is interoperable, means like I mean like You can operate from different environments. Like there is no interruption in the service because the network is always live with, let's say for example, network is huge with, let's say the Facebook server goes down or Google server goes down, Gmail server goes down. Like we can't do anything after that simply. So if let's say for example, in blockchain, if a particular server goes down, there are lot others which are live, right? So there are chances that it will go like there will be interruption in the service are very very minimal because the network is huge, right? So and then it's a permissionless, like depends on like what kind of blockchain again. So yeah, and there is like Web3 stack, which like you can say see. So like there are DApp browsers like MetaMask and all that. So MetaMask also provide browsers. Then we make decentralized applications, and then there is like storage. So like similarly you make your Java applications, right, in today's world. So what you use a compiler and then Java virtual machine as well, right? Similarly, Ethereum also use Ethereum virtual machine, and then there is a consensus algorithm. There is off-chain computing as well. Like we kind of, you can say, we actually make Web2 applications only, right, today, and we connect that with Web3. It means our data is decentralized, but we will have to use the application which are you like where users can simply interface, right? We'll have to deploy the application somewhere, so that will be centralized always. Then the data feed and all that. So then there are hardware clients and protocol network protocols. So quite technical. I'll not go deeper. We can talk about these in maybe later sessions if we have something. So now coming to the actual stack, Web3 stack. If you want to just dive into kind of, you can say, development of Web3, so you can. So these are actually layers. So my personal suggestion is like. Okay, try to know everything, but try to stick with something, because like you need knowledge, you can say specialized knowledge in a particular layer, so that you can be an expert of that. So so simply layer one blockchain means we are actually dealing in terms of layer one means like you are not actually dealing directly with the Ethereum virtual machine or kernels. So you are actually dealing in terms of high level, have a high level code only. And if you talk about layer two, like you are dealing below, like in terms of kernels, or in terms of like at lower layer of calculation simply. So the computation and all that, you are actually connecting at a lower level of computation. So simply if we talk about simple R computers only, so our computers understands binary, right? 0 1 0 1 1 0, something like that, right? So they don't know Python, they don't know Java, but we somehow made the compilers or virtual machines like that. So that particular compiler converts that code in a way, in a byte code, so that the computers can understand. Similarly, like happens with Ethereum also. So the EVM is that machine which converts the high level smart contracts into the low level byte codes, and then machine actually understands that. So then for file storage, you have the solution for development environment. So you can use any one of these, hard hat or truffle or foundry or brownie or anchor. Then for indexing inquiry, you can use this one. In NFTs, you might have heard IPFS a lot if you know about NFTs a little bit. So IPFS is something, it's a distributed storage. It's not like MongoDB or our DynamoDB or like SQL or something like that. It's something, it's a distributed storage which stores your data in chunks. So you can check about this as well. So then there are oracles, chainlink, and plugs. Off-chain data protocols are there as well, threaddb and all that. So then identity management system, as I told you, wallet connect is one of them. Then MetaMask and Solana wallet adapters, and there are a lot other wallets, so which provides you your private key and give you an identity as well. Then there are clients. So clients like JS clients are there for Py libraries are also there for Python, for Java as well. But I would suggest, like, if you want to actually dive into blockchain development, try with JavaScript mostly. But if you are a pro Python or Java developer, you can go with that. Like, there is no restriction in that. But the community, the you can say the coverage of JavaScript is quite huge. Like people are working with JavaScript and TypeScript a lot. So you will find a lot of work is being done with JavaScript only on the blockchain space. It doesn't mean like people are not working with Python, Rust, or like people are working a lot with Rust as well these days. So Rust and JavaScript you can explore, but there are others like Java, Python, and all others. So you can explore those as well. So now, uh, I included this slide just to show you the impact. Like, let's say, for example, this is simple PhonePe transaction settlement. So, like, let's say, for example, I pay someone from my PhonePe to someone's Google Pay. So, these many number of you can say settlements has to be done for that. Now, just take an example. If we are doing a cross-border payment, right, there will be a lot of intermediary again, and there may be a glitch at any point, right? That's why you see a lot of time going on your Google Pay transaction. Yes, PhonePe is fast, because of like their infrastructure, but still, I mean, if you do those transactions in a distributed environment or in a decentralized environment like blockchain, like you don't have to go through these many steps simply. So simply to transfer 100 rupees, like these many settlements you will have to done, right? So because ICICI Bank is the PhonePe is acquiring bank, and then Google Pay's bank is different bank, and then let's say for example I am holding an account of some other bank, and then the receiver is holding an account in some other bank, right? So these many number of settlements it takes actually in a Web2 ecosystem. And if I just introduce cross-border payments here, so there will be a lot of intermediary, right? But if I want to send some crypto to someone in US, I can send in like just in seconds simply. So I can do that. So that's the benefit actually of user-centric ecosystems. So there are chances of less failures. The speed is quite high, and the cost is very low. So if you do cross-border payments with traditional banking systems, you have to go through a lot of fees as well. So you will see that. So now, what exactly are the benefits of Web3? So Web3 is like you can say, actually it is providing the control to the user. So the traditional way in which we use applications today is we depend on a trusted third party, and we rely on them simply. But the Web3's way is simply decentralized. It means like the calculation can be anywhere in the network. So it doesn't guarantee that only you will do a calculation. Then there is no intermediary. There is more security because of the asymmetric key cryptography. You can explore this topic, asymmetric key cryptography. With there you will see public key, private key, and all elliptic curve, digital signature algorithms, digital signatures, and all those things. If you are interested in mathematics and cryptography, so you can explore that. Then it provides transparency because like you can validate the records, and it provides trust as well, because a transaction is actually being added based on an algorithm, not based on someone's opinion. Let's say for example, like in Twitter, like a lot of people got banned, but on blockchain you cannot actually do that because the control is not with someone particular. Then the role of cryptography is huge in blockchain or in Web3 ecosystem actually, because it provides the integrity of the ledger. Means like you cannot actually change something because it is dependent on hash. Now, when I was giving a definition of blockchain, I was giving an example of a notebook, right? So actually the pages are connected, right, with that spiral or with some binding, right, in a diary or in a notebook. Similarly, in blockchain, every block is connected in such a way that if you change one block, every other block after that will also change drastically, because a cryptographic hash function is such that if you change the input a little bit, the output will change drastically. Okay, so simply, let's say for example, the block 2 hash is a combination of block 1 hash and the root hash of all the transactions which are in block 2. So it's like you collect all the transactions in page number 2. Okay, you create a collective identity, then you combine that collective identity with the identity of block 1, and then you create the identity of block 2. So it's like that. So it means block 2, so like if you create a hash of block 3, you will use the identity of block 2, and block 2 has already used the identity of block 1. So it means every block is connected, right? And if you change anything in the blockchain, it will drastically change simply. And it is not possible because a lot of like the cluster is running, right? A lot of computer nodes are running in the network, right? So it is simply, actually, if you change at a, let's for example, if you hack the particular computer and the network is of 40 computers, right? 39 will say no, it is not correct, and it will synchronize the data according to what 39 have. So this is how it provides the integrity of the ledger. Authenticity means like you simply, I mean, your transaction is authentic means whenever a transaction is actually thrown, let's for example, I transfer something to someone, so that is actually signed by my private key. Okay, so and now people can simply verify like from whom this transaction came, right? So it actually provides that non repudiation, you can call it, or authenticity, you can call it. You can actually check, or you can actually verify from where this particular transaction was generated. Okay, now it provides privacy because of the pseudonymity, because as I told you, it is not in terms of plain text, it is in terms of hexadecimals, right? So you can it is actually pseudonymous. So then identity of participant is done through public and private key, which I have explained. And you get auditability and transparency. It means you can simply audit, like you can go to block 1 and you can check the data, whether a particular transaction was made or not. And transparency is because like it is with someone, it is a distributed database, right? So everybody has that copy that they can simply check their diary, they can check page number 5 anytime, and the transition will be same for everybody. So that's why it is transparent as well. So now coming to the challenges actually. So we actually rely a lot on third party today, because we are like, okay, why should I worry if my bank is taking care of my money, right? Why should I worry if Facebook is using my picture somewhere, right? What will Facebook actually do, right? But what if you lose your private data simply? Like, let's for example, it's your very, very personal data, right? And you don't want to share it with anyone. It can be your banking passwords, or and mistakenly it is on Facebook. Now it is with Facebook, right? And if, let's say for example, your this particular personal data gets leaked, and it happens, right? With these companies it happens. If that gets leaked, it means your bank account amount is also gone, right? So so that is actually the problem. But this is actually challenge as well for Web3 community, because we over rely on third parties right now, because we are actually we have become habitual of using like of not taking the control and giving control to someone simply. So then there's a lot of crypto negative marketing, because in market actually everybody thinks blockchain is cryptocurrency. That is actual problem, like that is the main problem which we face, like wherever we go. Like if I introduce myself as a blockchain technical person, they will say, okay, you work in cryptocurrencies, and cryptocurrencies are like myths, like they're nothing, they're something like that, right? So I'm simply telling them, or I'm simply telling you as well. So cryptocurrency is just a use case, and it can be a negative use case, and it can be a positive use case. I'm not suggesting you to invest in something, or not saying that. Like it depends on like whether you trust it or not. If you trust it, you will simply invest it, right? It same goes with stocks and everything, right? You invest in a particular company because you believe that particular company will grow. Similarly, if you believe like you invest in Bitcoin or Ethereum because you believe that particular community will grow and more people will ask for more Bitcoins, it means the value will increase because the supply is limited. So then comes the incomplete knowledge. So that is also a reason, because people think they know because they have read about Bitcoin, or they have read about some crashes, crypto crashes. They think that they know everything about blockchain, but blockchain is very like much beyond that. Like cryptocurrency is nothing in comparison to blockchain as a technology. So cryptocurrency is simply a like you can say a software use case or application, you can call it. So then like with more powers comes the more responsibility. I think it's a quote from Spider-Man. So like if we are getting the power of holding our private keys, it means we get more responsibilities as well. And we actually don't want to take that responsibility. So we don't want to take the responsibility of keeping our private key. We might lose it, right? We have that habit of forgetting something. So that is also one of the reasons, like we are facing this challenge that people are not moving a lot towards Web3. People are moving like at a very fast pace. The community is growing really, really fast, but still, like this is also a challenge in you can say adopting Web3 more. And then there are a lot of crypto crashes which are happening. You might also be seeing some crashes as well. So uh, there was a Luna wipeout. There was FTT crash which recently happened. So in Luna, what exactly happened was they created a stable coin. So if you understand cryptocurrency, you will understand some out of it. This explanation, I will just explain Luna one. FTT happens because of the mismanagement of funds, and Luna actually. So there was a stable coin. It means that the value of a particular coin will be pegged to a fiat currency. So fiat currency was USD. So now they actually didn't peg it with fiat value. They actually pegged it with algorithm. They with their native currency called Luna. So or it is a Terra platform. So what exactly happened? Like there was a massive, you can say, sellout of 2 billion or something of USDs, because people thought that. Like UST will depeg because of some negative marketing again, right? So then it started losing its value, like it went to point 0.9 USD, and then it started going down. So people will started panicking and they started selling. So as Luna was connected to our UST, so it started losing value. The generate, like you can say, the minting, or you can say the creation of Luna has started drastically. It was 1 to 1 pegging, but then it became 0.9 to 1, and then 0.8 to 1, and then the supply got increased massively, and then simply Luna also lost the value, because when you increase the supply, the demand reduces and the value reduces. If the demand increases, it means the value also increases. Then for FTT, simply what exactly happened with FTT or FTX is it lost the value because of the mismanagement of the funds. They actually took users' funds, but they actually didn't hold that many funds at a particular time. So what their competitor did is, Binance was their competitor. They kind of, you can say, sent out the news that they don't have enough funds. If all the users want all the funds in one day, they cannot actually pay everybody. So then people started panicking and they started selling the FTT. Selling their FTT tokens. Even Binance said they have a lot of FTT tokens and they will start selling them. So everybody started selling FTT tokens. It means again the supply increased and the demand reduced and the price went down and it plummeted simply. So these are the actual reasons where we are kind of, you can say, and now these crashes happened and people thought, okay, blockchain is gone. Blockchain is not gone actually. That particular cryptocurrency is gone. So it's a kind of, you can say, thought process which might need to change for this adoption to happen. But yeah, I mean, like it might take some time for people to understand what is the actual value of blockchain. So now what are the development needs, like what exactly, how you can start on it, or what exactly you can do. So before I go next, I will just say, if you are a front-end developer, if you are a back-end developer, or if you are a product manager as well, or if you are someone non-technical also, so just stick to that and add value of like you can say blockchain pieces with that. For example, you can become front-end blockchain developer as well. So in that, you'll have to know wallets, like how you integrate wallets in your applications, how you deal with smart contracts. I mean, like how you integrate with smart contracts. Not you don't have to develop the smart contracts. So you simply, like, how you can integrate with smart contracts. You can work on Web3 layer. So Web3 is the library which you can learn about. So that is going to help you out. Like it is for someone who is working actively on Node.js or React.js, or you can say front end or back end in any technology, they can learn Web3 library. So you'll have to know like how you interact with smart contract, how you send the data to the blockchain, how you receive the data from the blockchains, then how you deal with it like outside the blockchain as well, how you deal with wallets, how you do the transactions, how actually transactions are gone from wallets and all that, right? And then if you are a pro technical researcher or something like that, or a non-technical guy also, so you can learn about technology first, and then you start developing smart contracts. So you can become a smart contract developer or a blockchain developer, you can call him, or blockchain engineer as well, if you want to work on a protocol level. If you are a pro researcher also, so you can go down to your protocol levels as well, where you can research about cryptography, you can research about a lot of other topics which are involved, like peer-to-peer networking, then cryptography is there, then but there are a lot of other things, like you can simply go and check out. So yeah, and first I'll have to just like explain what exactly is a smart contract. So smart contract is nothing but a software program only. So it's a software program which will actually be a interface or layer between the blockchain and your traditional applications which you develop day to day. So you have to write a piece of code which will interact with the blockchain on the other side, and on the different side it will interact with your application through Web3 or through ethers, or through other libraries which are existing. And the execution, so it is actually non-reversible, as I said, like you cannot change the data in blockchain. So simply you'll have to make a transaction based on some validation, so your transaction might fail as well, because it is actually not following the rules which are written in your smart contract also. So and then it is like audit control as well. So there are, I think there is a lot to tell, but I will try to like fast pace this session now, so that we can finish on time. So like I can share slides later. So there is a difference in blockchain platforms and blockchain products. So how can I hide this one? Just one second, let me start. Yeah, so there is a difference. So blockchain project is something like you are creating your own block, like you are creating a application over any blockchain. It can be Ethereum, or it can be any other blockchain on which you are making an application. So it's a D app, like this distributed application you are making. And if you are making a blockchain platform, it means you're creating your own blockchain, like Ethereum, Bitcoin, or Polygon, or something like that. So then hash function, you can read about this. So I will share the slide, and you can just go through like what exactly is a hash function. It is a one-way function, as I told you earlier. And once you like you cannot create the input from the output, and it is deterministic, like every input will give you the same output always, and a small change in your input will change the output drastically. So these are the key features which I have been talking. Like it provides transparency, it provides immutability, decentralization, enhanced security, and faster settlements. I have explained all these things in my above slides. So if you want to go deeper, like whether you need a blockchain or not, so you can simply use this decision tree for that. Then like these are the development benefits. I have already explained them, but I can talk about them again. So like you get better transparency, you get enhanced security, as I explained with cryptography. You get efficiency and speed as well, as I explained. Take an example of a PhonePe transaction and cross-border transactions. Then you can reduce the cost as well. Same example I gave, and you can do the supply chain management. So there is you can take an example of any supply chain. Let's say, for example, Serum Institute was making Covaxin, right? Like if we wanted to do better or proper supply management, and it can be anything, like it can be our public distribution systems as well, right? So there a lot of scams happen, right? So if something is there, like where we can actually see, okay, whether the food grains is reaching to the poor people or not, so that is actually something very, very huge, right? So we are actually we can do the better supply chain management with that. So blockchain provides trust, robustness, verifiability. I've explained this, so I will not go over it again. So then architectures. So simply, this is quite technical. Maybe if I get time in other sessions, I will try to explain what exactly, like how a blockchain is made actually, what are the pieces. So a consensus layer is there, network layer is there. So as I was talking to you before, that how you can make a career on the blockchain engineering side actually. So you can pick these topics. So these are the like consensus algorithms or networking, transmission protocols, gossip protocols, like digital signatures, Merkle tree, how actually these works, and you can get the actual information out of it. Then like this is the Polygon architecture. So Polygon blockchain is there. So there is execution layer, Polygon network layer, security layer, and like Polygon is actually a layer 2 solution of Ethereum. So they have connected with Ethereum, but on a lower level. So what they do is they combine the transactions, and they kind of, you can say, send that in a single transaction. So that actually increases the speeds. It means they are making a batch of transaction in a single transaction. So and the batch is actually getting managed on their end, on their database. And this is an example of your private blockchain, or you can say permission blockchain, where you have an orderer, means like someone's who control the ordering of your transactions. Then you have publishers, or you have viewers, and like you can define access control and roles here simply with the Hyperledger Fabric. And you can create a certificate. You can create certificates for everybody, and you can revoke their certificates as well. If you give a certificate to someone to do something, so they can simply do that. If like you haven't given, they cannot actually interact with that blockchain. So now use cases. So there are multiple use cases you can work on. You can work on record storing, you can work on trading activities, you can work on supply chain, mortgage, and you can do like projects on all these use cases: real estate market, employment arrangements, copyright protection as well, government votings as well. As I gave an example of police complaints, also insurance claims also, where you can give better transparency to the users. And IoTs. So IoTs will come later, where we might need a proof of data. So we might need secure data of sensors. Some sensors are quite like you can say secure, and their data should not leak, right? So something of that sort. So then there are a lot of e-governance benefits blockchain provides. I have given example of voting. I have given example of police complaints. So in an ecosystem which is democratic, there you get a lot of use cases out of blockchain, because it is a like you can say transparent like you can say store of records. So there you can simply verify whether a particular thing happened or particular record was added or not. So it gives better transparency. So you get all these benefits. Like you can simply go through these. So this is a chart which you can use, which I also use from somewhere. So it will simply help you guys, because you might be using, you might be doing a different kind of jobs right now. So you can decide whether you are a technical person or not, and based on that chart, like you can actually decide what exactly you want to do with your blockchain career, if you want to proceed with that. So uh, there are smart city use cases as well. Like a lot of cities are getting smarter day by day, and green cities initiatives are also being taken as well. So there everything will be automated. Like we have seen, we have heard a lot of examples from Dubai, Saudi Arabia, and Qatar, and all that. So they're making smarter cities. Even India is working on that side as well. So you can pick up any use case where you can make an application, or make an ecosystem where like you can use blockchain. And then question and answers for you. So I just pasted it in the last, but yeah, it's like we had less time, so I had to do that. So if you have any questions, if you could not understand anything, feel free to reach me out on my LinkedIn. So I have attached my LinkedIn link in my profile above, so you can simply use that, and you can text me directly. And you have any questions, or if you want to connect as well to understand something, you can just simply reach me out. Yeah, so over to you, Akshay. Thank you so much for listening, and thank you everyone for attending as well. I am grateful that you all came online and took out time this 1 hour for this session. Thank you all. Thank you very much.
Thanks a lot, Mohit. On behalf of Analytics Vidya, I'd like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful. and hopefully we can conduct such more session in the future.
Yeah,
I
yeah,
hope
for
you.
sure, Akshay. Yeah, I'm looking forward to that. So yeah, obviously, like we will try to conduct more sessions. I could not cover a lot because, as I told your moderator Ekta as well, like it is going to take a lot of sessions to understand this tech. It's a ocean actually, ocean of knowledge. You want to kind of, you can say, you want to get into. So it takes a lot more sessions like this session. So I will try to be more a kind of, you can say, explanatory in upcoming sessions, because they will be kind of, you can say, particular topic centric. So yeah, I will try to do that.
Yes, sure. Uh, I hope you guys have filled the feedback poll. If not, I request you to please fill in the feedback poll, as it helps us to conduct more such sessions.
And if anybody has any questions, you can post in the chat channel also. I may might have a look on that.
Sir, there are questions, sir. There are 12 questions
Okay,
you can
okay,
answer.
12 questions. Okay, yeah, I will just check them out. Okay, so okay, one question is that does blockchain only and solely related to crypto, and we can adapt to normal bank cash transaction development apps? So uh, no, blockchain is actually not solely and only related to crypto. As I told earlier as well, cryptocurrency is just an example. Like Twitter is an example of Web2. Similarly, cryptocurrency is an example of Web3. So cryptocurrencies sometimes are a fuel, like because you need to pay the transaction cost, but they are utility tokens. So you have to first know the tokenomics. Tokenomics means you have to understand what kind of tokens or what kind of cryptocurrency you are dealing with. So it can be a stable coin, it can be a ERC20 token, it can be an NFT, or it can be a utility token like ETH, like Matic token. So it is actually not solely related to crypto. And yes, you can adapt banks simply. Yes, I'm not saying that you have to rely on crypto, but yes, crypto gives a lot of other benefits which your bank doesn't provide. So yeah, so I hope I could answer your question, Ataliba. Okay, next question is from Mayank. So, what distinguishes one crypto with the other one? Like, what makes one blockchain better than the other one? So, it depends actually what exactly a particular user wants. So, let's say, for example, there are three things actually. There is security, then there is a distribution, and then there is a scalability, which is called a speed, right? So, you'll have to kind of, you can say, trade off between these three. If you want more security, you will not get more speed, because you'll have to go through such type of cryptographic algorithms. You'll have to go through more miners. You'll have to make the system robust. So if you want speed, so you can go with systems like Polygon. So Polygon is a proof of stake ecosystem, right? No, Polygon is a layer 2 solution, sorry. Like I'm just explaining the difference between consensus layer only. So let's say, for example, if you use proof of work, it means the verification should be done from more than 50% of the network. But if it is proof of stake, means number of defined validators can do the transaction, can validate that particular transaction. So you'll have to decide based on these three factors. Like if you want more security, your speed will reduce, and you can choose something which is more secure, like proof of work ecosystems like Bitcoin and Ethereum used to be. And like if you need more speed, you can go with layer 2 solutions or some consensus algorithms where like you can where there is more speed simply. And then again, question is SHA-256 is the only method to encode and decode communication? So actually we use this in existing blockchain ecosystem. So the entire blockchain is dependent on SHA-256, but there are a lot of encryption and decryption algorithms available. So it is related to asymmetric key cryptography, Mayank. And uh, uh, I mean, like you can use SHA-3, you can use SHA-1, but because, like again, like to do the trade-off between speed, security, and the decentralization, like people like use this one initially in Bitcoin, and then it became a standard. So later on, if more powerful supercomputers came, so like people might switch to SHA-3 as well, which is 392 bits. So it depends actually. So it's not the only method to encode and decode. simply, to answer your question. Then can anyone change hash code? So I could not understand your question properly, but I will explain this in terms of like in terms of hash. So hash is something like you take something. Let's say, for example, if you take Mohit, it will give an output of fixed length only, like it is 256 bit. And if you keep giving Mohit an input, it will keep giving the same output. And if you write Mohit V, right, the output will drastically change in terms of content, but not in terms of length. Length will always be the same. So this is the property of hash function. The output length will always be same. The input can be 2 MB, or input can be 2 KB, or input can be 1 byte. So it will always be the same length output, but yeah, every input will have a different output. Okay, I could answer your question. It was anonymous question. So again, Mayank is asking, is there any exit criteria if a person who has purchased crypto dies? Can you explain that for private and public? So for private, actually, cryptocurrencies doesn't exist. For public ecosystem, it exists because they actually provide, you can say, the value through that to their projects simply. So exit criteria is like, let's say, for example, you should have all your funds in your non-custodial wallets always, like MetaMask or Wallet Connect or Trust Wallet or something like that. You should not rely on some centralized cryptocurrency exchanges. FTT was a centralized cryptocurrency exchange again. So it was again an application. It was a Web2 application, but based on blockchain. So it was using a piece of Web3, but not was completely Web3. So exit criteria is that you should keep your funds in a non-custodial wallet, and if you want to trade, then you can transfer to some centralized cryptocurrency exchange and you can do the trade. Then Ernani is asking, in the last part of the flow, you said that this process is thoroughly centralized, which is fine. But what to say about their encrypted payment system using their own coins? They are centralized. Yes, correct. Actually, when they're using their own coins, as I said, FTT was their own coin, and it was a centralized ecosystem. It means they're creating actually the value of their project out of that coin. It's like simply company creates stocks, right? Similarly, blockchain companies create tokens to kind of, you can say, give value to their project, right? So this is how people invest in them. They take some part of their total tokens, and this is how they invest. So you should first understand the difference between type of tokens, what kind of tokens you want to use. So there is a utility token which is actually used to pay the gas fees, or you can say to pay the transaction cost. And there are tokens which are project dependent, like FTT was there, Luna was there. So you should I would say you should invest in them like by doing all the research about them, whether they are going to be good in future or not. So it depends on that. So yes, some coins are kind of, you can say, centralized, but they are on a decentralized technology, like on blockchain, right? So you can see the transfer of those, but actually you don't know whether like they are the only owner of that, or whether they are properly kind of, you can say, managing the value of that or not. And can blockchain technology can be used in EVM? So Gopesh is asking that. So blockchain, so EVM is a part of blockchain technology actually. So Ethereum virtual machine is simply a computation method where you change your high level code to the byte code simply. So it's like, you can say, it's a box where you put something in very high level and you get something in a level where computer can understand your code simply. So let's say, for example, if I write Mohit Vashistha, and that will be compiled actually. So and then it will be converted into a byte code which computer actually can understand in terms of 0 and 1. So yeah. And Mayank is again asking, is there any YouTube channel that you can suggest for us to know about crypto and blockchain? Yes, I can answer your question by, so there is DApp University, and there are other resources as well. So maybe what I can do is, I'll have to just find, just 1 second. I'm just pasting for you here. Just give me 1 second. So you can go through, just 1 second. So, so DApp University is there, then Eat the Block is there, and these are the some links maybe you can use. So I'm pasting that for you. Just 1 second. So I have sent some links, so you can just go through that. And then Priyanshu is saying, can you suggest me some good projects to work on as a fresher? Actually, I made a project recently, but it seems like common crowdfunding. It's also mentioned security issues of my. So, Priyanshu, first understand the technology properly, I would say, and do a supply chain application, maybe do a police complaint record tracking application. And then there are many other use cases. So I've included a lot of use cases in my slide. So I will maybe Akshay and team will share the slide link, and you will find it in YouTube also. So you can pick up any of the topic related to smart city or anything, and you can start exploring about the topic. And like whether to use blockchain or not, you'll have to decide as well. You can reach me out if you have some questions about that. But yeah, like first thoroughly research about the use case, what you are going to do, whether blockchain is actually required there or not. And yeah, so based on that, like you will get your answers. Then apart from development, what are the roles which we can look over to those roles? So Mayank, you can actually, as I answered with the chart, so you can simply uh, I mean, go through any of the roles if you are not a technical person also. So you can go through that chart, and that chart will, I think, answer you. So that is also included in the slide. So now, next question is, what are the skills needed for a job ready level blockchain developer? So as I told, if you know React, just understand Web3 properly. So that will do for you. If you don't know React, try learning React first, because it's the easiest way to get into blockchain. And if you want to become a researcher, or a particular engineer, protocol engineer as well, then dive into like the blockchain layers, like peer-to-peer networking, cryptography, and all. Understand all the basic components first. And if you want to become a smart contract developer, then understand Solidity, or maybe Viper. Understand Solidity, Viper, Rust. So I would suggest Solidity and Rust first, so you can learn those languages, and then maybe, yeah, you can, I think, become a smart contract developer as well. Can you please share those links on public chat? Yeah, okay, yeah, sure. I will share those to everyone. Just 1 second, everyone. Okay, so I have shared it here. If you, and I have a lot of other information as well, where you can, let me just paste that information for all of you, so you can learn from here. So yeah, okay, I think there is a limit. I think there is a word limit, I guess. So that's why it's not allowing me to paste. But okay, let me just break it down. I'm pasting for you guys. So and try to kind of, you can say, digest as less as possible initially. Don't try to distract yourself. Just kind of, you can say, try to go through these resources one by one properly, and try to understand the basics first. So that is the basic requirement. So yeah, and some podcasts also you can follow to understand. So these are some podcasts. And yeah, there are some, I think, yeah, maybe you can use this information also. Yeah, so I've shared all the links I had, and if you need more information, you can connect with me on LinkedIn, and I can share more information. If you have any questions also, you can connect with me there. Are there any other questions? So I think,
No, sir. You have answered all the questions.
okay.
Thank you, sir. Thank you answering all the questions.
Okay. Yeah,
It's
if you have any other question, any of you, then maybe I can answer.
Sir,
Okay.
I have a question.
Yeah, please tell me.
Uh, the main characteristic of a blockchain is decentralization. How
Mhm.
does proof of stake affects on decentralization?
So let's say now proof of stake is something where you have like you can say you define the length of like number of validators in your network. Okay, so now first understand the difference between proof of work and proof of stake. So proof of work is something which works on the majority. Okay, so for example, you have 100 nodes, it means you need at least validation from 15 nodes. Okay, but in proof of stake, like what validators will have to do, they will have to first stake some amount. Okay, so for example, right now Ethereum has defined, okay, you need to at least stake 16 ETH to become a validator. Okay, so now let's say anybody can become a validator because it is a public blockchain. Okay, now I have become a validator, so now the network becomes small. So they say, okay, if these 8 validators or 10 validators, the length is decided by the network congestion. Okay, so if the network congestion is huge, the number of validators will be more. But I think they have defined the number of validators, so I don't know the number exactly, but so they define it, and they say, okay, that if the network size can be anything, if the network size is 1,000 nodes, 5,000 nodes, or 5 million nodes also, if this particular network, like small network, let's say a network of validators validates that particular transaction, so the transaction will be validated. So now how it affects the decentralization means, like decentralization was more when it was proof of work. If there were 5,000 nodes in Ethereum ecosystem with proof of work, it means at least 2,501 nodes had to verify a particular transaction. But in case of proof of stake, only the validators who have staked their ETH, who are validators, and that network is also small. They are not a network of 2,501, 501, sorry. So this network is small. So if they validate a particular transaction, so they will simply kind of, you can say that transaction will deem to be valid. And why they will not cheat with the ecosystem? Because the amount is huge. 16 ETH is a huge amount. If you try to cheat with this system, then system will simply take up your money. So it's like that. Could I answer your question, Akshay?
Okay, sir. Yeah, I got it.
Okay. If not, then maybe you can call me directly. You have my number also, so I can explain it a little bit further.
Yes, sir. Sure, sure. Thank you
Okay.
so much.
Okay. Welcome. Anybody else? Any other question or anything from your end?
Sir, you
Nothing?
got one more question from Shubham J.
Okay. Let me just check. Interesting talk, loved it. Okay. Thank you so much, Shubham. And what do you think of research area in blockchain itself? So, Shubham, you can pick up cryptography. You can pick up networking, like peer-to-peer networking. You can pick up gossip protocols, how messaging and all that works. You can pick up distributed file storage systems like IPFS, RWeave, and all that. You can pick up encryption, decryption, and digital signature algorithms, elliptic curve. So it comes under cryptography only. And then there are a lot of other things, like you can become an economist as well in cryptocurrency, right? Like these are crashes happen, but if we have better economists, like who can simply do the proofing before creating a particular algorithm or creating a particular rule, so you can become that as well. Good thoughts. Then enabling privacy, secure computation in multi-party cases, requirement for these are ever evolving as far as I believe. So yes, that's true. Like you'll have to, like you can say, constrain yourself with something particular. Like you cannot learn about all the consensus algorithms for sure, uh, and you cannot learn all the symmetric and asymmetric encryption and decryption algorithms as well. So yes, you'll have to constrain yourself somewhere, and you'll have to find your expertise. You can become a cyber security engineer as well if you learn cryptography properly. If you learn how a man in the middle attack happens, and it comes with cryptography actually. Because of the cryptography, we are secured and we are encrypted. Our data is encrypted. So if we want to secure ourselves from such attacks, then you can become a cybersecurity official as well. So yeah, I mean, security comes with cryptography. Yeah, could I answer your question, Shubham? Okay, answer. Thank you.
Okay,
Any
sir.
other question or anything?
No, sir. No, sir. Thanks for right now. Thank
Okay.
you. Thank you so much. Now it's time to end the session.
Okay, thank you, Akshay, and please try to share all those links maybe and with people. They are, I think, not able to copy my like pasted message in the chat. So if they can get these links, maybe it will be really helpful for them. And hope I could help a little bit. All of you, like it was fine talking to all of you guys. Even I don't know you, but still, like it was lovely connecting, and it was. Lovely sharing the knowledge which I had. And I'm looking forward to maybe connecting with you guys in person whenever, like if you see me anywhere, I'm traveling to Bangalore for ETH India and Polygon Connect. If you are there, just hit me up and maybe we can catch up there as well. So thank you so much again. And thank you for joining and thank you for connecting. Thank you for time. Bye bye.
Thank you, sir. Thank you so much.
Thank you. Bye bye. Bye bye, everyone.
Bye, sir. If you wish to conduct such webinars or facing difficulty in registering, connect with us at editor@analyticsvidya.com. The recording of the session will be available within 2 days on our YouTube channel. The link will be provided in the chat section. So, well, we'll be back with another session of data on uh, next on 29. The link will be in the chat section. Till then, bye bye and keep learning.